Once we move into the impedance domain, some circuits can still look crowded. Source transforms, Thevenin, and Norton give us a cleaner one-port viewpoint. The goal is not to change the physics. The goal is to preserve the same terminal behavior while using a simpler equivalent form. In AC, the source transform rule is the same idea as in DC, except resistance becomes impedance. A voltage source V sub S in series with Z is equivalent to a current source I sub S in parallel with the same Z, where I sub S equals V sub S over Z. The impedance does not disappear and it does not change value. Only the source description changes. Why is that legal? Because both forms produce the same terminal voltage and the same terminal current for any attached load. Open circuit the output and you recover the same open circuit voltage. Short circuit the output and you recover the same short circuit current. Matching those terminal conditions is the essence of one-port equivalence. This leads directly to Thevenin. Any linear AC network seen from two terminals can be replaced by one voltage source in series with one impedance. The Thevenin voltage is the open circuit terminal voltage, and the Thevenin impedance is the equivalent impedance seen from the same terminals. The Norton form is the current source view of the same one port. The same linear AC network can also be written as a current source in parallel with the same impedance. The Norton current is the short circuit current, and the Norton impedance equals the Thevenin impedance. The two views are connected by I sub n equals V sub th over Z sub th. So, the workflow is short. First, choose the output terminals. Second, find the Thevenin or Norton source together with the terminal impedance. Third, connect the load to whichever form makes the algebra easier. Series-friendly loads often look cleaner in Thevenin form, while parallel-friendly loads often look cleaner in Norton form. Source transforms, Thevenin, and Norton are not separate tricks. They are three ways of describing the same AC one-port. Once the terminal behavior is preserved, the load sees no difference. In the next lesson, we move to mutual inductance and the ideal transformer.